Ones I have Hampton is Bradley, Cicero's, Melton, Moreland, Gravy, Smith, everybody else I have here. Everybody get it? Everybody get that? Everybody get it? Nobody? You might see what that has to be. F of X has to be what? Because this has to be what? If this is F composite G sub X, wherever you see an X, you gotta put this in. Everybody see that?
Mm-hmm.
So this has to be F of X. G sub X would have to be what? This. No? Everybody see that? So if you put this in here, you'd have to be what? See that, everybody? G. This is F composite G sub X. Like that. You're just plugging in this every single place you see an X. So that had to start out as that, is F of X had to start out as this. Because you plug this in for X. Does everybody see it? Not enough of that. Okay, let's see what we got here. Quizzes. How about, let's see, we're looking at chapter quiz 4. Okay, right, well, it should make it, let's make it easy, if that's a piece of cardboard, okay? Two different things they can ask you about this cardboard. The first thing they could say is, I want you to cut it to where you make a box out of it, okay? And that would mean you'd have to cut the quarters out of it, right? That makes sense? So if you cut the quarters out, I'm gonna try to make some quarter cuts or whatever. And the quarter cuts are gonna have to be pretty much the same size to make it the ideal box, I guess. And if you draw the dotted line, like so, you can certainly make an open box out of this by folding the cardboard on those dotted lines. Everybody see that? So here's where something like this would be. Like, what if you had, that's 12 by 12. If it's 12 by 12, it's quite easy to see that if you do not cut that box at all, in other words, if x, the quarters is equal to 0, then you don't have a box. It's just a flat piece of cardboard, okay? You can also say to somebody, okay, cut the quarters out of this. They say, yeah, let me have it. I'll cut the quarters out of it for you. Let's cut a 6-inch square out of each quarter. Let's cut 6 inches out of each quarter. So in other words, they cut the box like this. That's 6, that's 6. And guess what? Again, you don't have a box. So in other words, the point I'm making is you are restricted. You are restricted physically on a domain that says what? You better cut something out of the quarters that has to be between 0 and 6. If you cut 6, you cut the box into 4 equal pieces that you throw away. So you can cut too much or you can cut too little. So what does that say about the box and how you cut it? That somewhere between 0 and 6 inches, you got to make those cuts. Well, that 0 to 6 like this has to be written like that. In other words, the x value has to be somewhere between 0 and 6. Can't be 0 and it can't be 6. Am I making sense at all? Now what if the x is real small? If the x is real small, then you're going to have a wider and longer box, but the height is going to be what? Just about this high. If you cut great big huge chunks out of the quarters, you're going to have it sort of narrow this way and this way, but it's going to be what? It's going to be tall. So the idea is to take and see what we can do with a problem like this, because you have to listen to us just for a second. Because here's the two different types of questions that could be asked of you, okay? The first question could be this: what if they gave you the size box? You've been given a box that is a piece of cardboard that's 12 by 12. What if you've been given a piece of cardboard that's 12 by 12? Then the thing that they would ask you for is what? What is the x value? What x value must I cut in order to do what? To maximize the volume of this box. That is one question that could be asked of you. So now we have to do what? We have to try to calculate what is the volume of the box and try to maximize the volume. Okay? That'd be like question 1 or whatever. They could, in fact, reword this question. Y'all better be paying attention, because this is going to come at you. You're not going to know what the hell hit you. They could come back and say, okay, this is the size box we want. This is the size box we want. You go tell me, what is the minimum size piece of cardboard that it's going to take to make this box? Do you all understand the two different questions? In other words, they could give you the dimensions of the cardboard and ask you, how much should I cut out of the quarters in order to maximize the volume of the box? Or they could say, we know what the volume of the box we want. You must tell me, what is the minimum size piece of cardboard that I must go get to make this box. You know, if they said, we want you to make a box that'll hold 2 cubic feet, I promise you, you could go get a piece of cardboard as big as this room. And you could cut it down to where you have what? You could make a box that would hold 2 cubic feet. But you'd have a heck of a lot of scrap left over. But that's not the objective. The objective is to do what? Is to make the box with no scrap left over. I hope you understand the two questions that I'm asking you. Okay? Does everybody understand the two questions? Let's take this one. Tell me what X has to be cut out of the quarters if I intend to make the biggest box possible. To make the biggest box possible. Make the biggest box possible. think this is right, is it? Okay, has everybody got it? Anybody got it? Yeah? Got it? Yeah, now draw a picture now. Yeah. Why do you wait till I always come by the desk instead of so? Y'all need to start doing this stuff. Okay, close. Okay, close. Close. Okay, close.
Is that right?
I don't know the answer. What you got? Ouch. Whoa. What's that? Did you get that? Yeah.
Just punch them in.
Huh?
I just punched them in.
That's it. That's guessing by golf, right?
Yep.
Stab a jail.
Yep, and that's why.
That's one way of doing it, though, yeah.
It's not accurate.
Yeah. Yeah? Hey, you got it, yeah? Is that what I? Let's think about this, everybody. What's this? This would be what? Volume is equal to what? Length times width times height, right? Somebody see that?
Yes.
So this is about what you have to do with this, everybody. The length is what? What about the length?
12 minus 2.
What about the width?
12 minus 2x.
What about the height?
12 minus
So the volume is gonna be equal to what? This is gonna be 144, right? And this would be what?
4x.
Right? Did I do this correctly? Then plus what? All times what? X, so the volume with respect to X would be what? 4x cubed plus minus 48x squared plus what? That is the volume with respect to X, okay? Now, this is where the pre-calculus class comes into play, because to solve this problem, is you would do this, you would solve this equation for X. That. Once you solve that equation for X, then you would have maximized the volume. Okay? So you should have just gotten it down to what? This right here. If you'd gotten it to here, then I could show you how to work it from that point. So, yes,
Are we still on chapter 1?
yeah.
We're
I
at
think,
approximately
okay, hold on.
section on what?
Chapter 1, section 4 quiz. You got problems a little bit like this. Oh, they're a little bit tougher than this one. Chapter 1, section 4 quiz. Down towards the bottom. Y'all see the whole picture there? Now, do you remember doing this, everybody? Do you remember doing the problem that looks like this? Y'all remember doing that problem? What you'd have, look, what you'd have to do to this problem right here, see this? Every single place you see an X, you'd have to put in there what? X plus H. Okay? Now, I would not ask you to do that. There's no way in the world that I'd have you plug in every single place you see an X, you put that in there, okay? Everybody okay with me? Do you all remember what this does? Who remembers what this does right here? Who remembers what that does? What did we do when we did this problem? Y'all remember what we did?
Something about a circle.
Okay, folks, this is the pre-calculus for you. This is the calculus part. You remember doing this problem like this? Isn't it? You remember doing that?
Oh, the depth of the U. It was something about a U.
No.
No. Well, then.
What we did is I asked you to go out here somewhere X and put a dot right there, and this would be x, comma, f of x, right? You remember that? Then I ask you, go a little bit farther out to here, and this would be what? Some number past x. Some number past x. And if that is the case then this value right here would be x plus h, right? Comma, what? That point would be right there, right? Still missed. No? Yes? Do y'all remember doing that? And then I came back and I said, why don't you do this? Why don't you draw a line through those 2 points? And if you draw a line through those 2 points, you now have a what? You have a straight line on this graph. You have a straight line on this graph, okay? Everybody with me? When you have been given a straight line, you can certainly find the slope of it, right? Everybody should know how to find the slope of a straight line. It is the change in the y values divided by the change in the x values. So if you did that, this is nothing more right here than the change in the y values. This is the change in the x values. And if you don't believe it, watch what I will do. This is f of x plus h minus f of x all over, that's the change in the y values, yes? Or no? That's the change in the y values. Well, the change in the x values is that. Does everybody see that? If you did the change in the x values, look what happens on the bottom. Now you just have what on the bottom? Just that. And remember what we did with that? We said, you know, if that's the slope of that straight line, then we should be able to allow h to get smaller. In other words, if we allow h to get smaller, then that's just going to do what? Just going to back us up this direction, right? And that's what they're actually telling you to do. And this is the way they write it. They said the limit as h goes to what? 0. Folks, this is precalculus. That's what this class is all about. This is what you have to know. So, if that is the case then, if you're allowing h to go back and get smaller, then that means if you let it go back to here, say, and then suddenly you're at the point right here. So now if you draw a line through these 2 points, look what happens. That's a different slope than the one you started with, right? That line has a different slope than what you started with. Okay? Well, let h get a little bit smaller. So now we are located here. And the dot is right there. So now draw a line between these 2 points. And what do you notice about that line? That line is not the same slope as the one before it or the one before that. So as you allow h to get extremely close to 0, you're sitting right on the other side of the x value. You're sitting. So what does that mean? This is now when you're sitting right on the other side of the x value. So, yeah, hell, see, you're not listening. So gee. Okay. Everybody, you all, just forget this, you know. Let me hurry and finish it where we can get past this and get on to something that's important, as if this is not. If you do that and you get extremely close to that point, you still have two distinct points. And those two distinct points are so close together that when you draw a line through those 2 points, guess what? It's just like the same thing as you drawing a line right there. And whatever you get, it will be the slope of that line at that point. Because those 2 points are going to be so close together that they're almost one. They are still 2 distinct points. But you can't imagine any space being in between them, even though there is space. It's so insignificant of a space that when you draw the line through those 2 points, you can literally say you have the slope of that line, this curved line, at that point. I can't make that much clearer than that. If you understand that, then you're going to understand what calculus is all about. Calculus is all about maximizing and minimizing. This is calculus 1 now. Is maximizing and minimizing things. Because, let me tell you something. If you have just calculated the slope of a line, if you've just calculated the slope of a line, and that line is not straight, that line is a curved line, like this. If that line is curved, there's going to be what? There's going to be critical points in which the slope is 0. That's why I said you have to now make this what? 0. I want to know what value of x will make that line 0. Because what I did, whether you realize this or not, but I applied what I wrote over here to this for you. And this is what you're going to get. This is what you're going to get. And so this is really the slope of this line. So what you're calculating is, where is the slope 0? Where is the slope? What x values make it equal to 0? You can actually divide everybody by 12. And this would become what? That, right? Everybody okay with that? If I divided everybody by 12. And if you factor this, everybody look at this a second. Can you factor this? Of course you can. You can. Both of them have to be minus. And one of them has to be what? A 2, and one of them has to be a 6. You have to have that. Now look at those 2 answers. Look at those 2 answers. Mr. Wilson, you had it right. You guessed good. You guessed right. Or did you do that? Did you do the calculation to get that?
I didn't do that.
Huh?
I didn't do that. Oh.
Yeah, fine. So, yeah, I did all that calculation about that. But he did, he was the one had the two. Did you see what you get up there, everybody? You get the two answers, and one of them's what? 2, and the other one is what? A 6. Who the hell's gonna use 6? We've already done what with 6. That's the extraneous value. You can pitch it in a garbage can. Because you saw a while ago, if we took a 6-inch cut out of the quarters, you have nothing. So the only legitimate answer that you have there is what? A 2. You cut 2 inches out of the quarters. Did you hear what I said? If you cut 2 inches out of the quarters, then I promise you, you'll have the maximum volume that box can be, and if it's 12 by 12. Try to cut something other than 2 out of the quarters. Right now. Try to cut 1.9 out of the quarters. Somebody cut 2.1 out of the quarters and see what volume you get. Or try something smaller than a 2. Try 1.8. If you put a 1.8 in there for X, what is the volume? If you put a 2.3 in there, what's the volume? Just try it and see. If both of those answers will be what? Do you recognize that this is what? This is quadratic, right? And guess what? It's like this, right? You know what this is called? That's the minimum. That's the minimum. That's the minimum X that you cut to maximize the volume of the box.
Mr. Smith, did you want me to hear this?
I'm looking for another problem real quick, just give me a second.
Okay.
very difficult to make up, but let's suppose I change the problem. And I ask you this question. Suppose that I ask you this, what is the smallest piece of cardboard that I have to go get if I'm gonna be told that I've gotta cut 3 inches out of each side, 3 inches out of the quarters, and I wanna make a box that will hold 588 cubic inches. 588 cubic inches. What would be the smallest cardboard that I would have to go out and get to make that happen? So do you see the difference between the two problems? This time I'm not giving you the size of the cardboard. This is where you have to go find the size of the cardboard that you're going to use.
You said it was 380,
588.
588 cubic.
Let's see how many of you can set that one up to make that one work.
Started the right way.
Did I tell you, Paul? Okay, look, everybody let's stop a second. Once you just set the problem up, that's pretty much all you want to do to it. Simply because, look at the numbers, 588, you know, let's go. You'd almost have to have the computer set for what? Quadratic formulas?
Mm-hmm.
To punch in the numbers A, B, and C are so big. So, you wouldn't want to have to sit here and do what? try to factor that, which would be probably pretty easy to factor. But, can you just set it up? Because the problems that I will give, this is what I just made up, because I couldn't find the one that was easy, okay? So this would be what? The volume is what? Remember we said we were gonna cut what?
X minus 3.
So, the volume is the width, which is, or the width is x minus 6 times x minus 6 times 3. So the volume with respect to x is x squared, right? Minus 12x plus 36, all times what?
X.
3. Everybody see that? So this was 588, right? Didn't I say that was 588? Right?
Yeah.
So if I divide the 588 by 3, I will get rid of this, and now we just have a lot. What is 588 divided by 3?
196.
How about you?
196.
So 196. 196. So if I did this, I wrote this as x squared minus 12x, and then I put the, what is 36 minus 196? Was 36 minus 196, because I'm
Negative
moving this over
160.
here.
Negative 160.
How about
Negative 160.
160?
Yes.
All right, everybody look at that. Everybody see that? Everybody see that?
And then you.
Okay, couple of things you could do here, right? Couple of things you could do. What's one quick thing you could do?
You find the I forget what it's called, but the point where the slope's 0.
Set
That's
the 0
what-
back here.
No,
Yeah, you just, I mean, that's simple multiplication.
Is what now?
That's just simple multiplication
What is?
to get that. That's just,
Right here.
yeah.
No,
That's x minus 20x plus 8. X minus 20x plus 8.
it's what now?
X minus 20, X plus 8.
I mean, that's what I got on my paper. And I mean, I know that you wanna know, like, what the greatest possible x is, and it's 20. Right?
What?
That could be up to it.
You could do this, you could say, okay, what is the vertex?
Yeah, that's what
You could say this, x squared minus 12x equals to 160, right? What's height this?
Negative 6.
-6, what's -6 squared?
36.
Put 36 back out there. Now you have what? This is x minus 6 squared. How much is this? Minus 196? So when x is 6, when it's 6 is the vertex, right? Or you could do this. Watch.
Hey.
Let's see if we could do that.
Okay.
What about finding,
Why were we finding the vertex?
well, and I'm just showing you all the different things you can find. You can find the
Okay, I mean,
vertex,
I was just
which would give you, the minimum. Cause this thing's gonna be like this, right? Can you factor this?
yeah,
Yes.
definitely. That's what I was trying to tell you, like earlier, I was saying x minus 20x plus 8. I mean, I guess I should've gone open parentheses x minus 20. close parentheses, X plus 8, close parentheses. That's what I was saying.
Okay, oh, okay.
I mean,
Yeah.
my bad.
Yeah, a couple of things, like I say, he just quickly did what? Factored. And if it's factorable, sometimes they're not factorable. What's the probability that they're factorable?
50-50?
Not very, not even,
No, I mean, it's not very.
not even 50-50, probably what is 100 is factorable? That's why I was looking for a problem that I knew the answer to, you know?
Yeah.
It's already made up, I just had to make this darn thing up, so. So you know where X is equal to -8, that's why. That was out. So when X is equal to what? When X is 20. When X is 20. So a piece of cardboard, 20 by 20, is the most ideal piece of cardboard. That's all you need is a 20 by 20, and you can make a box that will hold 588 cubic inches. You can't make it hold any more or whatever. That's the maximum. You maximize the volume with the minimum amount of what? Cardboard. You know you could go get a cardboard that's 10 feet by 10 feet and make a box. But you got a lot of cardboard you'd have to throw away. And that is not the way they want to do it. Besides, you can look at have you ever looked and thought about how the topology of this involved in making a pizza box? You ever thought about that? I mean, first of all, they want it to be strong, but they want it to also be what? When they get them, those boxes are not put together. Because why? Because it would cost a lot of money to ship them all put together. It would take up a lot of volume. So they come to the pizza shops and just flat crates on a pallet. They just flatten them. And they take that piece of cardboard out that's already what? Cut, stamped out, and what do they do with it? They fold it on the dotted line. Somebody had to do what? Make what? Had to do the math to make sure that they were not wasting cardboard. That they cut those boxes in such a way that they don't waste any of the cardboard. It's, and that's a lot of that's topology. And you know who has a great ability in topology of mathematics and they don't even know it? They don't even have a clue. Can anybody guess? How many of you have ever been in the Appalachian Mountains? You ever been in the Appalachian Mountains? What do you find?
Snow.
Little shops?
Snow.
You ever been with there's shops on the side of the road? What do you find in those shops? Some of the neatest puzzles you've ever seen in your life. Y'all never stopped and seen some of the puzzles that those people carve and make? You ever see the ones where they got the wire and they put the wire together? You're supposed to take it loose from you got two horseshoes hooked together with a chain and a ring around it, and you got to get that ring off there? Duh. Most people look at it and say, that's impossible. That's impossible, you can't do it. But do they come off? Yes. You know what that's called? Somebody in the Appalachian Mountains figured out the topology of that program, and figured out a way to do it. They're using topology mathematics and they don't even know they're using it. Just stop by the roadside and look at all the puzzles that they put together. The nails, they took nails and did what? Twisted them and they put them together. You've got to get them loose. How long does it take you? Forever sometimes. I got to sit there to get the instructions how to do this. What are the greatest topology? What is one of the greatest topology puzzles?
Rubik's Cube.
What?
Rubik's Cube?
Rubik's Cube.
Not that one at Cracker Barrel.
What?
At Cracker Barrel.
The one at Crackle Barrel.
Oh, no, that's simple. You can do that with your eyes closed. You beat the pegs,
Yeah.
Got teeth.
but the Rubik's Cube.
Logarithm.
Not only is that incredible for topology, but the mechanics of it is the most incredible part of it. I can tell you this, try getting on a telephone. And you're on the telephone and you're describing to someone the Rubik's Cube who's never seen it before. If you can imagine that. And you tell them that I have in my hands this device that has 3 slices, top slice, a middle slice, and a bottom slice. It has a right-hand slice, it has a center slice, and it has a left-hand slice. It has a back slice, and a middle slice, and a front slice. And I can turn the right side clockwise or counterclockwise. I can turn the middle clockwise or counterclockwise. I can turn the right side. I can even turn the top, or the middle one, or the bottom one, or the back one, or the front one. Now you tell me if somebody wouldn't tell you, man, you're out of your mind. That's impossible. That's literally impossible. So the mechanics of it is probably one of the more incredible things of all, is the architecture of it. Does everybody agree that with that? So
You know, a lot of people put it down, but it's actually pretty good. Domino's has got nasty pizza. They've got good sandwiches. Yeah, they've got nasty pizza. If they just give up on pizza and just focus on sandwiches, they would be impressive. You know, they could kill somebody.
back
You
up,
know, like
back
somebody, after I see one person say, can I get a different knife? And he goes, okay, because of what I say around knife. I never liked them. I like Jersey Mike's. I don't like Subway. Brittany doesn't love you. I really like her. I think it's so cute. I'm just waiting if I want to eat her. No, she didn't. She didn't text you. Because you're lying. Because I talked to Bridget yesterday.
okay, they give you one on chapter 2, section 4 quiz, and it's talking about a pumpkin chunking thing where they chunk a pumpkin, and they want to know, they give you the equation that the pumpkin travels. Now you go ahead. You go ahead and go.
Okay.
You go, it's. You need to go,
For me? Yeah.
it's Belton,
Me?
yeah.
Kinda. I have an interview at 2. I said kinda, but I have an
Okay,
interview at 2.
yeah, but you're free to go, yeah.
Well, you were still talking, I don't wanna be rude.
Well, you already packed up.
I don't want to be rude.
I mean, if you have to go, y'all go, so. I'm not gonna make anybody stay here, so.
Good luck on your interview. Thanks, bro.
It's called a Heisman.
Let's see, what's in section 1 quiz, how about number 2, let's see if there's some in there, number 2, for example, let me go back.
What's that?
Number 3, there was something there about when they had a, I think it's 4. Yeah, 4. Down at problem number 7 and number 8 and number 10, number 9, number 11,